In this video, I'm going to show you how I created an automated mask from a composited image in ComfyUI. First, let's look at the basic setup. I'm loading in two images, a background and a product. From there, I'm connecting them to a compositor config node, with the background in the image 1 slot and the product in the image 2 slot. Next, I wire the compositor config into the compositor node, and finally, a preview node. Here you can see the initial results. You'll notice both images are overlapping, so we'll need to do some pre-formatting. We'll start by making some space. Next, we'll add resize image nodes. This node will add black to either the top and bottom or sides, depending on how it scales the original image. For this demo, we want all of our footage to be 1024 by 1024, which will keep our footage consistent. Now we're going to remove the background from our product image. First, let's make some room, and then we'll add a remove background node. Now, when we execute our workflow, we see the product clearly cut out, allowing us to easily place it over our background. The compositor node allows us to scale by grabbing the corners of the control box and rotate by dragging the top of the controller. In addition, if you flip the image, you'll be able to tell by the line that shows up at the bottom of the control box. Now that we have our comp in place, let's work on crafting our mask. First, we'll need to get the position, scale, and rotation data from our compositor node. To do this, we'll connect the compositor transforms output node to the transforms output of our compositor node. As you can see, this node exposes the X and Y position data along with width, height, and angle. In addition, it also exposes the bounding box for both the position and scale as well. The channel field allows you to choose which input image is providing the data. Let's now move this node closer to our product image. Our goal is to craft a mask by transforming and combining the alpha of our product image with a solid background. To do this, we start by creating a CR color panel node and setting its color to black. We then set its width and height to 1024 by 1024 like the rest of our footage. This gives us a blank canvas to start with. Next, we add a mask to image node and connect it to our remove background mask channel. Our result is a black and white image of our mask. Now we work on combining the two images together with the data from our composite. To do this, we use an image transpose node. First, we wire in our background image. Then we add our image converted from a mask. Now we need to connect our composite transform data to our image transpose node. To do this, we need to convert widgets to inputs. We do this for all widgets with the exception of feathering. From here, we can connect X and Y, width and height, and rotation. Let's preview the results. Here, you can see the scale and position did not change. This is because we are using the data from the background image and not our product. To fix this, we need to change the channel we are getting our data from to 2. Now you can see the mask is in the proper position and scale. Let's add a comparer node to verify this. As you can see, it lines up perfectly. This is the basic setup for this workflow. It allows you to transform and scale to align the mask. Where things start to change is when we look at rotation. Here we have rotated the product. Let's have a look at the result. As you can see, the rotation is in the wrong direction. In addition, the scale is incorrect as well. Let's start with fixing the rotation. We do this by adding a math expression node between the angle and the rotation. We need to multiply the angle by -1, so we add this expression, a times -1. Now the rotation is fixed. So let's look at fixing the scale and position. Because we have rotated the product, we can't rely on the original width and height. Instead, we need to use the bounding box. To do this, we'll make a duplicate of our image transpose node, then wire the bounding box position, width, and height. As we look at the result from this new transpose node, we now see everything aligns correctly. We now need to set up a switch that will choose the correct transpose node based on if the product is rotated or not. First, we need to set up an impact compare node, which we will use to see if the rotation is equal to 0. Let's wire the angle into A, then we will create a constant integer of 0 and wire that into B. If both the angle and integer are equal, then we will get a result of true. If they are not, we will get a result of false. To visualize this, we can add a display any node. Now, we add a CR set value on Boolean node. This will allow us to output a chosen integer based on true or false. The final node we want is to add a switch image node. We will connect the first transpose to image 1 and the second transpose to image 2. Since we are switching between image 1 and image 2, we'll want to modify our set values to 1 and 2. We then need to convert the select widget to an input and then wire the integer from our Boolean to choose the correct image. Let's take a look at the result. As you can see, we get our expected result from a rotated product. Let's now remove the rotation and see what our result is. And we can see that our mask is still aligned properly because our switch used the original transpose. Now let's look at our results if we flip the image. As you can see, although we have flipped the image, our mask is not flipped. So let's look at the data coming out of our composite node. We use the display any node and wire that into transform. Here, we can see all the values output by the composite node. Since the composite node doesn't output negative scale values, we need to find another solution. There is a value called FlipX, which will output true if the product is flipped. So let's use this to drive a flipped mask. Let's start by adding an image flip node and adding it to the convert mask to the image output. Next, we'll copy our CR set value on Boolean and switch image nodes from below. After pasting the nodes near our flip node, we will connect the image flip into image 2 and the mask into image 1. The switch image output will then connect to our transpose nodes. Now we need to come up with a Boolean. We will use the FlipX result from our composite node. Let's add a text find node to transforms. And for our pattern, we will use the quotation FlipX quotation semicolon true. We can then move this node next to our CR set value on Boolean node and wire found into Boolean. If we look at the results, you'll see that nothing's changed. This is because we are switching to the incorrect image. We can adjust this by either changing the image inputs on the switch node or flipping the values on the CR set value on Boolean node. Now our flip mask works properly. So far, we have gone over how to control a mask based on a composite. We have also added a switch to choose a different mask based on rotation or if the image is flipped. The last step is to add our painted mask from the mask editor. Let's start by opening the mask editor on our background image. Then paint an area that could be a contact shadow for your product image. Let's copy and paste our CR color panel node. On this node, we will set the color to white. We will then add a resize mask, which is wired into the output of our background node. Let's add an image composited mask node. We will then wire the switch node into the destination and the CR color panel into the source. Finally, we will wire the resized mask into the mask channel. When we try to see our results, we get this error. This is because there is an extra channel coming from our switch node. To remove this, we will use a split image with alpha node and wire the image output into the destination. Our result is the combined mask from both the product and our mask editor. And here we could see the results in our compare node. At this point, you can use the mask with a convert image to mask node or further modify the mask with a grow mask with blur node. I like this node because it allows me to do things like fill holes, expand, and blur the mask. Thanks for watching. I hope this was helpful or maybe gave you some insights on how you can craft your own custom masks using ComfyUI.